Explorer 1. NASA's farthest-traveling rocket proceeds with its astonishing endeavor through space, impeccably imparting huge data from the most profound regions of the universe. For nearly 50 years, this exceptional space test has altered how we might interpret space. However, the space device has been conveying upsetting data back to Earth, leaving the whole space industry in shock. Are these alarming signs the consequence of a technical breakdown, or the activities of extraterrestrials? Join us as we uncover the truth behind these shocking transmissions. Since the dawn of history, scientists have been enchanted by the insider facts that lie beyond our superb limits. This interest provoked the notable launch of the Voyager 1 and Voyager 2 spacecraft, among other outstanding space missions. These earth-shattering missions, which had been examined for a long while, started with the launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5th of that same year, Voyager 1 followed suit. These twin tests, each weighing a critical 720 kilograms, equivalent to a small vehicle, were pushed into space during a special arrangement of the outer planets. Throughout their amazing odyssey, these brave journeys explored various directions and velocities, leading to a crucial moment on December 15, 1977, when Voyager 1 outperformed its indistinguishable twin due to variations in their paths. From that point forward, Voyager 1 has become a huge resource, providing us with an abundance of data and unlocking space-related privileged insights. Before we dig into Voyager 1's surprising new discovery that shocked the entire space industry, let's take a look at the excellent pictures captured by the rocket during its critical Jovian imaging mission in 1978. Voyager 1 was situated around 265 million kilometers from Earth. From this vantage point, it sent back an astonishing number of photographs to Earth. In January 1979, it embarked on a unique 100-hour attempt to capture a mesmerizing time-lapse film showing 10 rotations of Jupiter. A cornucopia of 3,750 images allowed us to witness Jupiter's sublime dance in distinctive detail. In the ensuing months, Voyager 1 wandered through the Jovian moon system, making a striking discovery: the presence of a small ring surrounding Jupiter and 2 new moons, which further expanded our understanding of Jupiter's captivating area. To ensure safe passage and prevent a possible impact with Titan, one of Saturn's moons, corrective maneuvers were executed. Voyager 1 continued its divine venture around Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, and Rhea. With the climax of the Saturn mission, scientists decided to conclude the Voyager planetary mission, pushing both Voyager 1 and Voyager 2 beyond the limits of our planetary system, speeding through space at a staggering pace of 325 million kilometers per year. In January 1990, a new chapter began: the Voyager interstellar mission. During this stage, Voyager 1 delivered some of the most famous photographs in history, immortalizing the Sun and the majority of the planets. One individual who played a crucial role in extending the missions beyond their initial goals was the renowned astronomer Dr. Vasil Sands. As part of the Voyager mission's imaging group, Dr. Sands passionately advocated for capturing one final series of images as a farewell gift to humankind. Against all odds, his unwavering determination bore fruit on February 14, 1990, when Voyager 1, situated 6 billion kilometers from the Sun, embarked on a visual journey known as the Planetary Family Portrait. These dazzling images, totaling 60, added to the spacecraft's exceptional collection of 670 photographs during its encounter with Neptune. Explorer 2 achieved a remarkable milestone by recording wind speeds exceeding 13,100 meters per second, making it the fastest wind ever recorded in our solar system. As the spacecraft ventured within 280 million kilometers of Neptune's blue methane atmosphere, it provided us with exceptional insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed to be one of the coldest bodies in our solar system, with surface temperatures plunging to a bone-chilling -391 degrees Fahrenheit. Triton's unique features, such as its nitrogen gas-emitting ice volcanoes, which hurled frozen particles 5 miles into its sparse atmosphere, also fascinated our imagination. These extraordinary revelations expanded our appreciation of the vast variety and complexity of celestial objects residing in the farthest reaches of our local planetary system. Don't go anywhere. The Voyager 1 spacecraft has recently made one of its most terrifying discoveries. However, before we explore what it has accomplished in the past 45 years, let's first reflect on its many remarkable achievements. The accomplishments of the Voyager twin spacecraft have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left researchers in awe and shattered previous assumptions about these distant worlds. These moons, once believed to be dormant and heavily scarred like our own moon, turned out to be teeming with geological activity. Voyager 2, in particular, achieved several significant accomplishments during its journey. It made history in 1986 by becoming the first spacecraft to fly by Uranus. Just 3 years later, it achieved another remarkable feat with a flyby of Neptune. To this day, it remains the only spacecraft to have traveled such a path. As the Voyager spacecraft continued their journey, NASA implemented various measures to extend their operational lifespan over the years. Unnecessary parts and heaters were deactivated to conserve energy, ensuring that these bold pioneers could continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the researchers and engineers who have been involved in this extraordinary project from the very beginning, the culmination of the Voyager missions is both a moment of pride and a bittersweet farewell. Their unwavering dedication and passionate efforts have far exceeded initial expectations. The wealth of data returned by the Voyagers has provided invaluable insights, spurred numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Voyager 1 and Voyager 2 were no ordinary space probes. They were meticulously designed as steady platforms with a rotation rate more than 15 times slower than the hour hand of a clock. This design choice minimized visual blurring as the spacecraft captured images and data while traveling through the infinity of space. Indeed, even before their encounters with the outer planets, their remarkable imaging capabilities began to astonish researchers and the public alike. The spacecraft started transmitting images of Jupiter before even reaching the gas giant. These early images, showing the swirling clouds and famous Great Red Spot, thrilled audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected unmistakable signals from Io, which were confirmed by the detailed images they captured. Towering volcanic plumes and a surface scarred by volcanic emissions were revealed, with one of Io's most prominent volcanoes erupting with a force more than 100 times greater than Mount St. Helens, covering an area roughly the size of France. While the spacecraft's cameras were eventually powered down to conserve energy and memory before their journey into interstellar space, it's important to note that the images they captured did not include Mercury and Mars due to various factors. In addition to Voyager 1 and Voyager 2's interstellar probes, NASA has also operated other notable spacecraft like Explorer 10, Explorer 11, and New Horizons. Voyager 1 passed by Explorer 10 on February 17, 1998. Marking the moment when Explorer 10 became the most distant space object ever launched by humans. Voyager 1 itself continued its solitary journey for another 14 years before finally entering interstellar space on August 25, 2012. Though no other space probes were in sight to observe, NASA did not publicly announce this extraordinary achievement until 2013. What strategies ensured the success of the Voyager missions? One key strategy stood out as especially brilliant: gravity assist maneuvers. These maneuvers played a crucial role in propelling Voyager 1 and Voyager 2 on their bold mission to explore the outer regions of our solar system. To reach these distant destinations and collect vital data, the spacecraft needed more than just their own propulsion systems. They required a boost, and gravity assists provided exactly that. Imagine the two Voyager spacecraft, Voyager 1 and Voyager 2, embarking on their magnificent tour of the solar system. Rather than relying solely on their engines, they engaged in a cosmic dance with some of our neighboring planets. These heavyweight planets formed groups that performed an astonishing dance using the immense gravitational pull of these giants to slingshot the spacecraft on their way. This technique allowed them to conserve precious fuel and gain the necessary speed to visit various destinations. The principle behind a gravity assist, also known as a gravitational slingshot, is to transfer some of a planet's momentum to the spacecraft as it passes by. Picture Voyager 1 approaching Jupiter, a massive gas giant with a matching gravitational pull. With precise accuracy, Voyager 1 passed by Jupiter at the perfect point and speed. Jupiter's gravity tugged at the spacecraft, accelerating it to a higher speed and giving it a significant boost. Performing a gravity assist maneuver requires exceptional accuracy. Had Voyager 1 approached Jupiter at the wrong point or speed, the slingshot could have caused a devastating deviation from its intended course. The brilliant minds behind these missions executed these gravity assists multiple times, propelling the Voyager spacecraft on an extraordinary journey through the solar system. Voyager 2, for instance, used gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These divine maneuvers were of crucial importance in making this magnificent journey possible. The Voyager missions owe much of their success to these gravity assist maneuvers. Voyager 1 went on to reach interstellar space, with Voyager 2 quickly following, beyond our natural limits. As we await further data from the ongoing investigation into Voyager 1's anomalies, let's consider the surprising journey of these pioneering spacecraft and the wealth of data they have provided us. The accomplishments of Voyager 1 and Voyager 2. Jupiter and its moons. Voyager 1 captured a mesmerizing 100-hour time-lapse of Jupiter, displaying 10 rotations of the gas giant in clear detail. New moons and rings. The spacecraft discovered a small ring around Jupiter and identified 2 new moons, vastly expanding our understanding of Jupiter's complex system. Saturn and its moons. Safe passage maneuvers ensured safe entry close to Titan, one of Saturn's moons. Voyager 1 uncovered 4 additional moons of Saturn: Mimas, Enceladus, Tethys, and Dione. Neptune. Voyager 2 recorded the fastest wind speeds ever recorded at 13,100 meters per second on Neptune. It also revealed Triton to be one of the coldest bodies in our solar system, with surface temperatures plunging to -391 degrees Fahrenheit, and observed nitrogen gas-emitting ice volcanoes. Interstellar mission. Voyager 1's entry into interstellar space in August 2012 marked it as the first human-made object to do so. This achievement was publicly announced by NASA in 2013. Famous photographs. The light blue dot picture taken by Voyager 1, situated 6 billion kilometers from the Sun, remains one of the most famous photographs in the history of space exploration. The role of gravity assist. The success of the Voyager missions can largely be attributed to the use of gravity assist maneuvers. These slingshot techniques, where spacecraft gain speed and direction changes by passing close to massive planets, were crucial in enabling the extraordinary voyages through the outer planets. By carefully planning these maneuvers, the missions conserved fuel and extended their range far beyond their initial capacities. Deep Space Network, DSN. The DSN played a vital role in the success of the Voyager missions. This network of giant radio antennas, located in California, Spain, and Australia, enabled continuous communication with the spacecraft. It facilitated the transmission of data back to Earth and sent commands to adjust the spacecraft's trajectory and instruments, ensuring that the probes could continue their missions despite being billions of kilometers away. Current anomalies and investigations. Despite the remarkable engineering and robust design of Voyager 1, new anomalies have raised questions. The unexpected signals suggesting uncertainty about its exact location and the switch to a malfunctioning computer have puzzled researchers. NASA's investigation centers on a communication and control system, the AACS, Attitude and Articulation Control System, which may have malfunctioned, causing it to send data through a slow, broken computer. Environmental factors, such as infinite radiation and extreme temperature changes in space, could also have affected the spacecraft's equipment, leading to data corruption or memory errors. While less likely, the possibility of interference by intelligent extraterrestrial beings remains a topic of speculation. Future possibilities and legacy. As we continue to explore the anomalies of Voyager 1, its legacy and that of its twin, Voyager 2, remain firmly rooted in the annals of space exploration. The missions have not only expanded our understanding of the outer planets, but also demonstrated the resilience and ingenuity required to explore the vastness of space. Their estimated mission end date in 2030 marks the culmination of decades of scientific discovery and technological advancement. The data and insights gathered by these spacecraft will continue to inform and inspire future missions, ensuring that the spirit of exploration and the quest for knowledge embodied by the Voyager missions will remain alive and vibrant as we venture further into the universe.